Hello! Today we talk about trees. This is my second tutorial and I hope I have learned a bit more in the English language in the last year. And since I've made the walkthrough tutorial of the Houdini texturing asset, I decided to make another tutorial, in that case about those trees. And what you see right here is a 4K rendering of those so-called vertex trees that I found about 2 weeks ago on Gumroad. The nice thing on those trees is that they come with Vertex Maps, and this is really good for using in Houdini. So I decided to grab them, to buy them, to build an asset that everyone can use. So what you get at the end is a file, an add-on basically, where you can bring those trees to life inside of Houdini and of course with the render engine Redshift. And the nice thing is that those trees are procedural from the beginning. So what we see here now on the rendering screen is very detailed. Those trees are very detailed. All come with displacement maps, and the rendering itself is also done with translucency on all the needles. And all of the trees have some differences in shading. Of course, that sounds very complicated in the shading process, but that's not complicated because the asset comes with only one texture set. So all the 8 trees are working with the same shader, with the same texture set, and all look a bit different. The nice thing about this is it's very easy to integrate them into your shot without the need to correct things, that a problem that we know from photo scanning, or at least from photogrammetry, where you have different lighting conditions in the scanning. But this entire asset comes straight out of the box and works. Where can you get those trees? Simply on Gumroad. When you look for the Vertex Trees in the search box, you get those trees. It's the first entry right now. You also get some of the content, so you can basically grab one tree, test it for yourself, and if you be convinced to think those trees are really nice, you can grab the entire bundle and get the money for the first tree back. This was one of the points that drove me to the decision to buy those trees. And with this download, you not only get the 3ds Max files and the textures for 3ds Max, but you also get Cinema 4D files if needed. But what we need is the FBX files and also the textures for the FBX. And this was another reason to buy those trees, because most assets you can get in nature stuff is made for V-Ray and 3ds Max, and you only get those 3ds Max files, which are useless for me when you don't want to use Autodesk products. So yeah, you get all the textures and all the FBX files, and when you download that, you get a bit more. Oh, wrong folder. You get also some of the textures. Oh, I don't download that. But what I want to say is you get a manual to this, and the manual describes what it's all about, the trees, and gave me a clear indication how I have to translate those stuff to Houdini. So what you see here in this description manual is you get only this texture set. This is a representation of a shader system, I guess made in Cinema 4D, And yeah, all those vertex maps are inside the file. So when you download this, you basically have to import one of those FBX files. You get 8 of them. So the most important thing is that you import those FBX files directly into the OBG network. So I grab one of those trees now. We take the 8th tree and import that. This will take a while, I guess. And now what you see is you get some errors, but that's not a problem. You can completely forget about this. So we hit OK, and then we have this file in that object container. And right now the tree is very, very large. This is because Houdini is working in meters and Cinema 4D is working in a centimeter space. So what we need to do is to scale those trees down. Means I grab the transform node and divide that 100, divide that 1 by 100, which basically get 0.01 as a result. So this is the correct size for Houdini of the tree. And the next thing we need to check is, are there some of those vertex attributes? And what we see right now in the geometry spreadsheet is that there are a bunch of alpha point attributes, floating values, also vector values for CD until CD10. The only thing we need at this point are those CD values, because those CD values have variations. You see it when you scroll down the point overview. And what we don't need are the alpha floats. So when we scroll down, everything is 1. This is something we don't need. So what we do is attribute delete. And in this attribute delete, we basically type alpha and a star behind that. That means every alpha attribute, attribute with the name alpha will delete it at once. The next thing we don't need is the second UV. I really don't know why we have this in the asset. I think that's something for 3ds Max or Cinema 4D specific, but in Houdini we don't need that. So I deleted that too. And after that, really important is to write this down to your disk, because the entire scaling process, deleting of those stuff, is a bit time consuming. Also the import of the FBX, we don't need to waste that time. So it's a good idea to bake this initial export process down to a BGO file. So this would basically the path. We make it relative. Oh no, it's not. I guess this has to be the correct path. So let me check. Yeah, that's the correct path. So relative path $hip / and then the tree BGO. BGO is the native file architecture for Houdini, where you can store everything, including volumes. Yeah, this is the initial setup for importing those files. When you like to import the other trees, it's very easy, because all those trees have a contouring number. When you look inside the asset download, you see the first tree has the number 1, and so on and so on. So basically you can duplicate this entire geometry and only has to change those numbers, and then you get complete other tree when you uncheck this, because that's the sign that this is baked. So here's the another tree, and you see the import takes a while. So I already did that entire process here, and I will dive down into the biggest tree in number 8, and inside that asset you will get everything. So basically you only have to bake out the simulation. Maybe you tweak some stuff in the dot network, like the strength of the wind, or you change the ground plane, but overall it's everything inside the file. So the entire asset that you get with the download in the tutorial is completely pre-made. The only thing you have to do is to grab this wonderful trees from Gumroad, from Darstelling's art. That's the artist name. Where is it? Vertex Trees. It's created by Darstelling's art. So the only thing you have to do is to download this tutorial with the tutorial file, and you have to buy these trees in order to get everything working. And yeah, in this asset all trees are pre-made. Everything has to work out of the box. Maybe relinking of the textures in the map network is required in order to be able to render everything, but I make sure that everything is relative. So you only have to create the texture folder where you copy in all the textures. Maybe I changed the name of the textures. I can't remember yet, but it's fair easy. You only have to move all those files and change those files. It's a bit of handwork, but it's fast. And if you have one of those trees, you simply can copy paste those to the other trees and delete them and paste it in, and it should work. So this is everything. When you have one tree, you can use those shaders on all trees. Let us dive back into the tree asset. What I've done is I built 2 trees. The first tree is the simulation tree, or the simulation branch. Everything on the left side is built for the simulation, and on the right side I cached out the high-res geometry of the tree and feed everything into a point deform. The point deform is where the magic happens. Means the point deform is averaging the influences of those simulation points and translate those trees according to the simulation geometry. This is really handy. I use it almost every day when I simulate something, because it really helps also on complex geometries. And when you maybe remember my T-Rex, my entire T-Rex works with the point deform. It's really an awesome tool. So I used the same because the idea was not to simulate every branch. Every branch and every needle to simulate would take maybe hours on my computer, because every one of those trees has more than 2 million polygons. This is unusable, and I also don't like to model trees completely procedural. This is because I personally believe it would take a lot of effort to get a realistic procedural tree. Also because nature isn't procedural. When you look at this in a basic, on a basic context, so it would require a lot of work to get realistic looking procedural trees. So my decision was, I need some trees now, and I built an asset that helps me to mimic a bit of natural, or give those trees a natural feeling, a natural moving in the wind, maybe some of this. So the nice thing on those trees is we get vertex maps, and we can use those vertex maps directly in Houdini. So what I did is I loaded those trees right inside Houdini and looked at those attributes. What do we got? We got different maps. I used the attribute swap to visualize them, port them, or to transfer them to the native CD attribute channel, so that the viewport can grab those attributes directly and show it directly in the viewport. And when we dial through the different vertex channels, we see so we see that there are different channels for different purposes, like the moss, and also a decay shader for both of the diffuse maps. There are a bright diffuse map for the main bark and much darker version. So this decay helps to blend between both. This is really nice. And when we switch to CD9, we have a CD value where all the needles are selected, and some other stuff. I guess the 8 were the small twigs and stuff, and we have additionals here in CD7 and so on. So we can use this. What we don't need at the moment, or for the simulation, is all those tiny needles, all those twigs, those tiny twigs. We don't need that, because this would definitely slow down the entire simulation. This is not what I want. My key target was to come to 5 seconds per frame. This is my initial idea, to simulate a tree with 5 seconds a frame. So what I grabbed was the CD2, I guess, and in the attribute swap, and then I blurred this value. So I blurred it very, very much, so that you get at least a value of above 0. And it doesn't matter if you only get a 0.0001 or lesser. It only is important that those trees and branches get a value above 0 for the later work. And then I promoted this attribute CD to primitive level, because the attribute blur works only, I guess, on point level. Also, those vertex attributes are only on point level. And then I used a little expression that I delete everything that has a value of 0. So I switched delete non-selected, and I select with the expression everything. I select everything above 0. Yeah, the delete sub will delete everything what we don't need. We only need those branches and the trunk itself. The next thing is I deleted the point attributes, all of them. We don't need them for the simulation. And then I added a poly extrude only for extruding those very thin branches. Those original branches are very, very thin. This would not work in this simulation, or it would not look good. Also in the remesh section below. So I extruded them, a bit. Only with the point normal direction, not the edge normal. So yeah, everything has a fair thickness. The next thing that I've done is I thought about how I can connect those branches with the main trunk. The problem is when we don't have connected parts, and some of the trees have disconnections between branches and trunk. So how can I be able to get everything of those into one mesh, those that I can use this for the FEM simulation? So the idea was to scatter points. I scatter a lot of points, in that case over 900,000, and also use the distribution method to be able to have a very nice distribution, very evenly. So, and then I created a VDB from particles, VDBs from particles of the tree or of those points. And I used some very, very small values because I don't want a big blob. When I turn this up, I guess when it's not exploding, it will look ugly. Maybe it will crash my space, don't know. But it takes a lot of time. So back to the value. Yeah, so here we got it. So deactivate, activate. So this is our vertex tree as a VDB, and then I smooth the VDB to get rid of those tiny crevices and all this tiny detail we don't need for the simulation. On some smaller trees it's really a problem because those smaller trees have more fine detail that we don't need. So that's why I use a VDB smooth SDF. The SDF is basically, for people which don't know this, a signed distance field, which is basically some type of skin procedure to smooth the outer skin, so-called skin of the VDB. And then I convert everything to polygons with the convert VDB sub. The problem with this is we get also a lot of fine small details in the mesh or in the tessellation, and that's something we don't need. So the next step that we need to do was to remesh the entire thing. Triangulated meshes are working better in FEM. My initial idea was to use the vellum solver, but for some reason, maybe my lack of understanding of the vellum solver, I don't know, but it wasn't working when I pushed some wind and some movement to the trees. The trees would initially collapsing. Also, the strut system doesn't work, so I decided to go with FEM, and FEM works really nice at those structures. So now, after the remesh calculation in the remesh sub, we have a very nice distribution of triangles on the entire tree. This is exactly what we need. And next thing, maybe in case we have some problems, I use the clean sub to get rid of overlaps and maybe orient some problems, orient some primitives. But I think in most cases the trees are really nice, so this is not needed. I guess on 2 trees, on the smaller trees, I had some problems. That's why I have the clean sub inside of this. The next step that we needed to take was to get rid of the normal attribute, only because it's a lot more data that we don't need on the disk. And then I stashed everything out. Stashing in Houdini is basically nothing more as to force Houdini to store the data or the model data or simulation data or whatever directly into the file of Houdini, into the HIP file. That means those data is stored directly. When I disconnect this, you will see the tree is there. There's only one problem with stash nodes. When you rename your file, currently it has this name with the ending version 2, v2, and when I would name it v3, it can happen that the content of the stash file will vanish. So this is something I don't really know exactly, but there's a trick that you can use. You can, I used it on my helicopter to bake stuff down directly into the file. You can grab a retopo. Oh, where is it? Topo tool. Where is it? Topo build. Oh, it's called Topo build. And on the Topo build, you can maybe grab one point and move that simple point, maybe a very tiny way. Oh, that's not correct. So, and when you move one of those points, the entire mesh gets stored in the Topo build. And when I disconnect this now, it will store forever in the file. And it doesn't matter if you have another name, or it doesn't matter if you rename this. Yeah, Topo build is a nice hack for storing data inside the file permanently. But we don't need it in that case. So I use the stash to bake it. Maybe you have changes in the initial setup and only need to push stash input, and then it's baked. The next step that I done was to create a null for the rest position branch, which is here. But first I needed to create a solid embed. This is something that comes where when you use the shelf tools for FAM, and this solid is optimizing the entire mesh again. You can create another max TED scale. I pre-prepared these values for every tree, and the only thing you need to do is to select a new ground plane in case you have another ground plane, and I guess everyone which is using those trees will have another ground plane. So yeah, you need to feed in your new ground plane inside here, and then the only thing that I did was to extrude to create some sort of volume for the ground plane, so that we can use this resulting volume to create a pin group and automatically select some of the most bottom points on the tree mesh. I gave the name pin to it, which is referring to the simulation asset. And I also did a little attribute wrangle setup, which basically overrides the FAM stiffness values inside of the FAM simulation. And I also tested every tree and made some pre-setup to it. So basically you have different values in every tree inside of this attribute wrangle, and currently it has a value of 2 million on the largest tree. And I also created a ramp. This is something which is really nice because it basically means the tree is more stiff at the ground, at the bottom, and gets less stiff at the top. This gives some really good results. When you don't use the ramp, your tree can basically break in the middle or in the half, especially on those large trees. So this ramp is basically created with a relative box function based on the y parameter, and I created a ramp for it. That's a curve ramp where you can specify how much the tree should bend. Nothing special. And on the end, I multiplied the ramp color value with the stiff value, and this gets fed into the simulation asset. And in this simulation asset, we see basically what is happening here. There's the problem. So, and in the simulation asset, it's normal. It's nothing special. It's just the shelf tool. I added a wind force to it, and I drive the wind force with motion FX. And in the motion FX, I only multiplied the value, the animation value, with noise, which is changing every frame. You be able to mimic a very realistic wind result where the wind is not constant every time. The wind is changing. Sometimes the wind blows more or less, so the noise function can be changed, adapted, and changed like you want. And this value gets fed into the wind force. It's important to set the default operation to set always, otherwise the wind force will not be visible, because the initial means, from my understanding, that it only works at the first frame of the simulation. When you set it to always, you make sure that the value will be fed or refeeded every frame. That's important. And then basically gravity parameters, and yeah, the constraint with our pin group. It's a bit hard sometimes when you don't have this context drop-down menu, but you can remember we created a group called a point group called pin, and this is exactly the same group that we feed in to the constraints. So here are the constraints from the point. It's exactly the same points. So when we look at this, those points are here, and those are the constraints. Sometimes on some trees I created additional strings in the tree itself. I guess in the number 5, I guess. Number 5, no. Number 6. Number 6. In number 6, I added a bit. Oh, I need to bake the stuff before. I already deleted every stash. Because when you stash all the trees, your file size will grow up to almost a gigabyte of data. So in the final process, it would maybe better to don't use the stash nodes, to bypass them. The simulation will take longer then, okay, but that's okay. So we need to go here. Yeah, there. So, and what we see here is that I created some connections in between of the different branches. That's really important because the point deformer has problems when the mesh is expanding too much. Means when some of the needles get selected on the left side of on the main trunk and the other branches moving away, that could result in unexpected behavior. Means the needles can get stretched in a very weird way. It doesn't look correct. It looks like a broken mesh. To prevent this, or to get away with this, my trick was to create some springs between certain points to hold those branches together, so that they don't move a lot through the entire space of your scene. So, but this is a trick that I only did, I guess, on 6 and 7. On 8, 5, 4, 3, and 2, and 1, I don't need that. So back to our tree. And yeah, and basically the rest is easy. I turned down the in the solver, in the FAM solver, I turned down the precision from 64 to 32. It's a bit faster, not much, but it's a bit faster. And I also changed the integrator from this one to BE1, which is really faster. This is default value, but this is really slow, so I turned it down to BE1. And I also deactivated collisions, something we don't need, because those in normal conditions, those branches don't collide with each other. So I also deactivated that. And then we have a very fast simulation. I mean, 2 seconds per frame, or maybe 3 seconds per frame. It's really fast. Yeah, they are moving. So this gets fed. That's the DOP import for the simulation right here. Maybe, yeah, okay. And the another thing that we needed was the rest position that I spoke about a couple of minutes ago. The rest position is needed in the middle input of the point deform, so that we can drive the mesh with the point deform based on the changes of the model, of the rest position model and the new simulated model, and this gets interpolated with the tree model. So when we change this here, I already baked out the entire simulation, which looks like this, or maybe this. So better this camera. So the tree is moving slightly under wind conditions, and the point deform will help us when we don't have a viewport bug. So, and when we now scrub through those timelines, through those trees, we see slight movements. It takes some time depending on the tree. I also changed the minimum points amount. The small trees need less minimum points, and some of the trees need very large values, but we can dial it down maybe to 5. But this can result in very strange behavior sometimes, but it will update really, really faster. So it looks from a distance okay. So, and this is the entire setup basically. What I added was the Redshift network. So I added the proxy render workflow gives the advantage that Redshift don't need to translate all those points every time on every frame when Redshift is rendering. So to avoid those additional calculation time, you can bake them out. You can bake out entire scenes to a RS archive. And the most important thing is, when you work with that, is to ignore the OBJ visibility settings. That means when you would turn this off and you have turned off your setup, which is here, and bake the content here, when you hit render to disk, you would the resulting bake will be empty. To avoid that, recommendations would to activate the visible flag and then bake it out. But why should I keep an asset which is only a setup visible? So I turned this off and activated ignore OBJ nodes visibility settings to get rid of this problem. So you only need to keep the render proxy visible. Inside of the render proxy is nothing more like the Redshift proxy sub. There's no settings. The settings are made inside of the parameter tab, where you load every tree that you've baked out to a RS archive. And when you do changes, maybe you change the simulation or change something else, or change the shader setup itself, maybe you deactivate the displacement, or when you need to change displacement settings here, it's currently deactivated. So when you don't want to render with displacement, keep those check marks off, and then you go inside, bake it out, make sure that the path is correct. Maybe you like to have another one, and then you deactivate and activate the proxy file in the parameter tab of the geometry proxy, and then you can basically start rendering. So I will turn the other trees off and start rendering. And here it is. This is the tree. And it's really fast. And with a proxy setup, your file is sometimes faster by 1/3 of the render time, of the overall render time. 33% faster. That's really nice. So yeah, you can get the entire scene with the entire setup directly on my Gumroad profile. So you can go to Gumroad, Alexander Weide. There you get my Gumroad profile, and I will upload it right here. So you will be able to download it directly here, and it will be free, of course. So yeah, it's up to you. I hope for your support. If the personal intention to do this tutorial was also because those trees are really nice, and I like to support artists that made really nice work. And Darstellungsart is an artist from Germany. I personally hope he will move over to Houdini one day, but it's okay if not. But his trees are really, really nice. And if you have also questions on the asset itself, on the download on Gumroad, you can write an email to Darstellungsart. He's a very friendly guy, and he is answering those mails almost immediately. So yeah, if you have a question or a request on the trees itself, write to him. And if you have a suggestion on the tutorial or on the asset itself, drop me a message on Vimeo or on Facebook, or yeah. So I hope this asset will bring you fun, and yeah, I wish everyone a nice day.